Hello students, welcome to Educate. We are going to study numericals on chapter number 10 of class 11th physics. So let's see the first question. The first question says the triple points of neon and carbon dioxide are 24.57 Kelvin and 216.55 Kelvin respectively. Express these temperatures on the Celsius and Fahrenheit scale. So if you remember the relation, how are these scales related? C upon 100 equal to F minus 32 divided by 180 equal to K minus 273 divided by 100. Right. So values are given in terms of Kelvin. So here you will put the value. So let's write C upon 100 equal to K minus 273 divided by 100. So 100 will cancel out. So C equal to K minus 273. We have two values. One is 24.57. So first, suppose it is C1. So we write 24.57 minus 273. This is first value. And C2 next value is 216.55 minus 273. So this is value in a degree centigrade. Now, if you want to find out these values in Fahrenheit, so take these two. So F minus 32 divided by 180 equal to, in place of K, write first value 24.57 minus 273 divided by 100 and simplify for first value. For second value again, F minus 32 divided by 180 equals, here you should write that one second value 216.55 minus 273 divided by 100 and simplify. So you can easily get the answer. Now let's see second question. Two absolute scales A and B have triple points of water defined to be 200 A and 350 B. What is the relation between TA and TB? So in first it is 200A, in second scale it is 350B. So you can say TA upon 200 must be equal to TB upon 350. And you have to relate these. So TA is equal to 200 divided by 350 times TB. 0 cancel out. So 4 upon 7 times TB. This is TA. Right? So question is done. Let's consider next question. So next question says you are given expression for resistance. So you know resistance R equal to R0 1 plus alpha T minus T0. This is basic relation. Now here the resistance is 101.6 ohm at the triple point of water at this Kelvin and 165.5 ohm at the normal melting point at this much. What is the temperature when the resistance is this? So we can write the relations. First we write here first resistance like 101.6. So 101.6 and then here one thing we can do, we can write it as R0, then thing will become easier, right? So we will assume this 101.6 as R0. In that case, this is one resistance, this is another resistance, so this will be R1 and that will be R2, and then we can easily solve it. So we are going to apply this way. So first temperature, first resistance is 123 point this much, and temperature is to be found. The second one is 165.5 and corresponding temperature is this much, right? So it can be easily done. So let's write these values. So 123.5 equal to R0 is given as 101.6 into 1 plus alpha and T minus T0. T minus T0 is this temperature 273.16, right? So this is first equation, and then from here either you can get the value of alpha, so that will make things easier. So what we can do, 123.4 divided by 101.6 equal to 1 plus alpha T minus 273.16, right? And subtract this 1 from here. So 123.4 minus 101.6 whole divided by 101.6 equal to alpha times T minus 273.16, right? So this is first. Further, if we simplify, we can subtract it. It will become 21.8 divided by 101.6 equal to alpha times T minus 273.16. Correct? This you can assume as equation number 1. And then you can proceed with the second resistance when value of resistance is 165.5. So here you can write 165.5, right? And then corresponding temperature is given. This time it is given as 6005. Sorry, so here we can write that temperature. So it will become 600.5 minus this 273.16, right? From here we can get the value of alpha easily, right? So let's simplify. So take this here, 165.5 divided by 101.6 equal to 1 plus alpha, and this you can subtract 600 minus 0.5 minus 273.16. You can calculate. This is simple calculation. So from here we can get the value of alpha. So one more line I am writing, then later on you will do other things. So you can simplify this and take this one to this side. 165.5 minus 101.6 divided by 101.6 equal to alpha times. You can subtract this. So after subtraction you will get 273. So 373.34. 373.34, right? So you can get value of alpha from here, and that value of alpha you can put here to get the answer. It will be value of T will be around 384. So here calculation is little difficult, but it can be done. Now here there are certain questions. Theory question: the triple point of water is standard fixed point in modern thermometry. Why? What is wrong in taking melting point of ice and the boiling point of water standard fixed point? So it is obvious. These points like boiling point of this melting point of ice or boiling point of water, it may change with change in pressure, but triple point of water will remain fixed. Means it is independent of external conditions. And what is next question? There were two fixed points in the original Celsius scales as mentioned above, which were assigned the number 0 degree centigrade and 100 degree centigrade respectively. As I have told you that one is lower fixed point and other is upper fixed point. On the absolute scale, one of the fixed point is the triple point of water, which on the Kelvin absolute scale is assigned the number 273.16 Kelvin. What is the other fixed point on this? So you know that there is difference of 100, so you can get it. So you know absolute 0. So here upper fixed other fixed point you can get by adding 100, correct? So that's simple. Absolute temperature Kelvin, T is related by this Why do we choose this much in this relation and not this much? So here, triple point of water on Celsius scale is 0.001. Here, the important point, triple point of water on Celsius scale is 0.01 degree centigrade and not 0 degree centigrade. That is why difference of this 0.01 will make it. This is 15, this is 16. So difference is this. Correct? And what is temperature of the triple point of water on the absolute scale whose unit interval size is equal to that of Fahrenheit scale? So how will you evaluate it? So for that you have to find out the unit size in the two scales and then we will proceed. So we can say how many divisions are there in Fahrenheit. Do you remember? There are 180 divisions, whereas in case of Celsius there are 100 divisions. So we have to equalize the size, and for that we can write 180 divisions of F must be equal to 100 divisions of C. Correct? Because if you remember, difference between, they represent the same height even if divisions are different. So here they are saying what is the temperature of the triple point of water on an absolute scale whose unit interval size is equal to that of the Fahrenheit scale. Okay, so we can say 1 degree will be equal to, here 1 division equal to, so 1 division or 1 degree if you write of F will be 100 divided by 180 division of C. Correct? That is 5 by 5 by 9. Now, here there is another concept. 1 division of C degree centigrade is same as 1 division of Kelvin. Correct? Because there are 100 parts in each case. So here triple point on Kelvin scale, if we want to find out, here question is absolute scale whose unit interval. Okay, so triple point on Kelvin scale, we put the value, it's just opposite. If we go in centigrade, so it will be 9 by 5 parts will be equal to, in centigrade division, just a reverse of it. So we can write 9 upon 5 multiplied by the value of this, how much we are going to take, 273.69, 273.69, and then we can evaluate it. So that is answer. Let's take next question. These questions are little typical and they are value based. There is no calculation as such, so don't worry. Here in this question, information is given. Triple point of water is this much, and pressure thermometer A gives triple point of water this much, and this, and here normal melting point 1.797 into 10 power 5 Pascal, and here 0.287 into 10 power 5 Pascal. Now, what is the absolute temperature of the normal melting point of sulfur as read by thermometer A and B? This is first thing. Second, what do you think is the reason behind the slight difference in the answers of thermometer A and B? So if you notice the difference, 1 point. Here you are going to evaluate and then you will check the answer. What further procedure is needed in the experiment to reduce the discrepancy between the two readings? So let's see how to solve it. So triple point of water and normal melting point of sulfur. So let's write them. It says T triple is equal to 273 Kelvin, and in pressure scale it is given as 1.25 into 10 to the power 5 Pascal, right? And pressure it's given, normal melting point of sulfur is given this much. So normal melting point is given as 1.793797 into 10 power 5. Now what do we want? Actually, what is our purpose? So we have to find out the absolute temperature of normal melting point of sulfur as read by thermometer A and B. So for sulfur, it is simple. What we apply, the formula is T equal to P divided by PTR into T triple, right? So this formula we can apply, and this gives how much? It will give, P is given, it is 1.797 into 10 to the power 5 divided by PTR, that is given as 1.25 into 10 to the power 5. So you can evaluate it. Here one thing is missing. I have put this value and we have to write this one also. T triple, that is 273, right? And then you can evaluate. So this is one part. And now if we consider pressure thermometer B, the same thing we have to run. Actually, in this question, what you have to do, it is simple. Just take this, you have this divided by this multiplied by 273. Our concern is simple. Similarly, first you will write this value and then divide by this value into 273 and you will get the answer. So don't worry, it's not difficult. Correct? Did you understand what is our purpose? The purpose was to find T, a temperature, right? What is absolute temperature of normal melting point of sulfur? So absolute temperature can be found by applying just this formula, these values, normal melting point divided by triple point of water here in this scale, triple point on this scale, multiplied by actual triple point of water in degree centigrade. So that is 273. Correct? And then just put the values. So it will be 1.797 into 10 to the power 5 divided by 1.25 into 10 to the power 5 and multiplied by 273. Similarly, for second one also same thing you have to run. You have to do. You will write this divided by this into 273. I think you have understood. Okay. Now next question is, a steel tap 1 meter long is correctly calibrated for temperature 27 degrees centigrade. The length of a steel rod measured by this tap is found to be 63 centimeter on a hot day when the temperature is 45 degrees centigrade. What is the actual length of the steel rod on that day, right? here there is temperature difference. 63 degree, this is 63 centimeter on a hot day. This is total length, and temperature difference how much? This is 45 degree, this is 27 degree. So there is increase of temperature 18 degree, right? And here coefficient of linear expansion is given. So which formula you are going to use? So you know formula is L equal to L0 1 plus alpha delta T, right? So here this is changed length 63. So 63 equal to L0 is to be found 1 plus alpha. Alpha is given as 1.2 into 10 to the power minus 5 and into temperature difference. And temperature difference is here 27, this is 45. That is 18 degree. And now we can evaluate. So L0 is to be found. This value, whatever you are getting, 63, and divided by this, you can evaluate 1 plus 1.2 into 18 multiplied by 10 power minus 5. So just to simplify, it will become how much? So it will be around 63, because the temperature difference, this value will be very small. So almost there is very slight change. So roughly equal to 63 centimeter, right? So this is simple. There is no considerable increase in length, so that is why calculation is almost same. Now we are going to take next question. A large steel is to be fitted on a shaft of the same material at 27 degrees centigrade. The outer diameter of the shaft is 8.7 centimeter, and the diameter of the central hole in the wheel is this much. The shaft is cooled using dry ice. At what temperature of the shaft does the wheel slip on the shaft? Assume coefficient of linear expansion of the steel is to be constant over the required temperature range. Here alpha steel is given. Question is again based on same rule. The rule says L equal to L0 1 plus alpha delta T. So here a large steel wheel is to be fitted to a shaft of same material at 27 degrees centigrade. The outer diameter of the shaft is this much, right? 8.70, and diameter of the central hole is 8.69 centimeter. The shaft is cooled because here it's more, so it will contract, right? So, and what is difference? Difference between the two is 8.70 minus 8.69, which is 0.01, and alpha is given, so you can easily evaluate. So how will you proceed? So let's write it. L equal to L0 plus L0 alpha delta T, right? And L minus L0 equal to L0 alpha delta T. So first of all, L is 8.70 minus 8.69 equal to 8.69 into alpha. Alpha is given as 1.2 into 10 to the power minus 5, into delta T, right? So we can evaluate delta T, right? And when we have got delta T, then from there, since we have to find out the temperature, it says at what temperature of the shaft does the wheel slip on the shaft, so you can find the difference. Because one temperature is already given, that is 27. New temperature you will get after evaluation, it will be certain negative value. So that is based on your calculation, you can do it. Now let's do question number next. So question number 8. Question number 8 says a hole is drilled in a copper sheet. The diameter of the hole is 4.24 centimeter. So diameter is given. So say it is L is how much? It's given as 4.24 cm, right? And temperature is given 27. What is change in diameter of the hole? See, it is 227 degree. So what is change in temperature here? 227 minus 27, that is 200 degree centigrade, and alpha is given. So you can easily find. So apply the formula. This is diameter. So change in diameter we have to find out. So let's apply the formula normal. So L equal to L0 1 plus alpha delta T, and we put the values. L is to be found. L0 is given as 4.24 into 1 plus value of alpha is given as 1.7 into 10 to the power minus 5, right, into temperature difference, it is 200. You can evaluate it and you will get its value around, here it is 4.24 centimeter. Here our concern is what is change. So change means you have to find a delta L, right? So just simplify it, and delta L will be L minus this value 4.24, right? Because L minus L0 is delta L. So delta L is to be found, and this will get multiplied to this 4.24 multiplied by 1.7 into 10 power minus 5 into 200, right? And then simplify, and this will come out to be 1.44 into 10 to the power minus 2 centimeter, right? So we have done till question number 8. Other questions we will do in next video. Thank you for watching. Team Educate.